My homies. Yeah.
All right, so we already talked about difference of squares. You don't need to write this. We did the easy ones. So now let's do the ones, oops, come back, where we have to do U substitution. So this example right here. So we have 81k squared minus the binomial a plus 2 being squared. So how would we do this using U substitution? What would we let U equal? A plus 2, good. So let U equal A plus 2, which now turns our equation into 81k squared minus U squared. Can we factor that? Hopefully. That would be what? 9k plus U, 9k minus U. And then what do we do? So I have the limbo song in my head whenever I do factoring completely. In these problems, I have the plug it in jingle in my head. Plug it in, plug it in. It's just my brain works in song. So 9k plus a plus 2. Anything to combine there? Any like terms? Nope. So just leave it. And then we have 9k. Now this is where we got to be careful. When we do minus a plus 2, where do you think you're going to lose a point? You won't do what? You won't distribute your negative to that 2, right? So really it should be 9k minus a minus 2. So make sure you distribute it all the way through. So we get 9k plus a plus 2, 9k minus a minus 2. Okay, so difference of squares using U substitution. Got it? All right, so now can we go to sum and difference of cubes? All right, so what are your perfect cubes? We know that my perfect squares are 1, 4, 16, I missed 9, 25, 36, 49, so forth. What are your perfect cubes? 1 times 1 times 1 is, it is, what's 1? 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. What's 4 times 4 times 4? 64. 5 times 5 times 5?
125.
6 times 6 times 6? Jalen had that with the 216.
Yeah. I don't even know.
Just remember it. What about, what would be 7 times 7? 49 times 7, 28. Yeah, 343. All right, we don't have to go anything further than that. So, when you have two perfect cubes being added together, oh, we're going to skip perfect square trinomials because those are easy. I guess I have subtracting first. We'll do subtracting first. So whenever you have two perfect cubes being subtracted from each other, the following rule applies. So there's no trick, there's no cheat. It's straight up memorize the rule. So whenever you have x to the third minus y to the third, and you're asked to factor it, your result is always going to be a binomial times a trinomial. Oh, my battery's going to die. We can do it. So where does the first binomial come from? Well, if I take the cube root of x to the third, I get x. If I take the cube root of y to the third, I get y. This stays the same side as your sign as your original, so minus minus. And then your trinomial comes from the following. Square your first to get your x squared. Square your last to get your last. Your middle term comes from them being multiplied together, but notice that this right here is a minus, and what's the sign here? It is a plus, so this will always be opposite. Always be opposite. So if we start out with a minus, it's going to be a plus in the trinomial. If we start out, let's just write it here while we have it. So if we did the sum, if it was x to the third plus y to the third, what would be the first binomial? X plus y. And then the trinomial would be x squared minus xy plus y squared. This will always be a positive, because think about it, if you ever square something, it's always just going to be a positive, right? So it always will be plus y squared. Okay? So, sum and differences of cubes. Let's do some easier ones. M to the third minus 8. What's going to be my binomial? M minus 2, good. Because the cube root of m to the third is m. The cube root of 8 is 2. What's going to be my first term? M squared, plus or minus? Plus, good. What's the middle term?
M negative 2m.
Well, don't worry about the sign, just do the multiplication. So 2m plus 4, because it's 2 squared. Got it?
That's it?
Yeah, that's the factored form. Again, there's no, it's just, you got to memorize it. That's what it comes down to. All right, 27x to the third minus 8y to the third. It's the cube root of 27x to the third. 3x minus 2y. What's your first term going to be?
3x squared.
Square the whole thing. 9x squared, plus or minus, plus
6xy.
good, plus
4y squared.
good. That's your factored form. What would have changed in our problem if it originally was a plus?
It would 3x plus 2y and then negative.
So this would turn into a minus.
Subtract.
Right. Okay?
Wait, why that?
I just said, what if we changed it
Oh.
from originally a minus to a plus? All right, so now let's do some U substitution yet. So skip, skip,
So
skip.
plus the first one will be minus.
So if it was this one, it would be r plus 3, and then r squared minus 3r plus 9, right? All right, so let's do a U substitution. Where are you, U substitution? There we go. Let's change that t to be like a y or something. That'll make our lives easier. Change that to y to the third. So our t's and pluses don't look the same.
So
Right. Okay, so let's do U substitution. What are we going to let U equal? X plus 2, which turns us into U to the third, plus Y to the third.
And it just be u
U plus Y, parentheses,
u squared plus, no, subtract.
minus, good.
uy
Oops, doesn't really matter.
y plus y squared.
Plus Y squared, good. And now what do we need to do?
Substitute.
Substitute it back in. So now we get X plus 2 plus Y. Can I combine anything in here? No. You may be tempted to reorder it in standard form. I would just leave it like that. Don't even worry about doing that. Over here, we end up with x plus 2 squared minus u times, or nope, not u, x plus 2 times y plus y squared. Can we simplify this? What's that going to? What's x plus 2 squared? Go.
X squared plus 4.
No. How quickly we forgot. How do we get the middle term? Multiply it. X times 2 times 2. From last chapter. 4x plus 4. What do we get here when we multiply? Sometimes it helps to put that y in front. So what's a negative y times x? Negative xy. What's negative y times 2? Negative 2y. Bring down your plus y squared. Is there anything in here that I can combine together? No. So leave it. So there it is. Factored out. Hardest problem you'll see. Okay? Questions? All right, so use